The case study is about telecommunication, whereby the question is saying you have been consulted as a certified big data analyst by a telecom scam organization to do an analysis on their past records and produce a report that will be used for making organizational decisions by senior executives using the information provided in the case study report above. I want to believe, is this the question which you are supposed to tackle? Maybe you may confirm. Chair, is this the question?
Yes, confirmed.
Okay, thank you. So my task today is to present only subsection 1, which says outline how a big data analytics lifecycle process will enable you to produce the report, and state the tools and techniques that you would employ in processing the data. That's the question which I am supposed to tackle today. Right, can you confirm if you are seeing my screen, everyone?
Yes, we can see your screen.
Yes, sir. Yes.
Okay, thank you. Since this question might take long a little bit, I will try to summarize it so that all the concept, maybe we get the sketch and the direction where it is going to be. The gist of the presentation, you may maybe finish yourself as I'm going to share the response to the question. Right, much of my presentation will be on application of big data analytics lifecycle. I will be shortening it as BDEL into enabling us to produce this report and stating the tools and techniques that I would employ in processing the data. First and foremost, we are going to depict the big data lifecycle, which is which we have acronymed it as DDAPLA-BICO, right? Standing for discovery, preparation, data preparation, model planning, model building, communication results, and operationalization. So we have just short named this as what? DDAPLA-BICO, whereby the D, discovery, and DA, data preparation, then PLA is actually for planning of the model, and then B is for building of the model, CO is actually communication, C is for communication, and then O is for operationalization. Right, on this one, actually when applying the BDL, we have to actually do, we used actually the objectives, team members and their roles, then the tools and the data sources on each and every stage of the BDL. That is, on discovery, we shall be applying the OTD. And then on data preparation, we shall be applying the what? The OTTD. And then on model planning, we shall be applying the OTD. Model building, we apply the same. Communication of results, we apply the same. Operationalization, we also apply the same. So we'll be actually looking at objectives of discovery, team members and roles on the discovery stage, then the tools which are going to be used on the discovery stage, and the data sources which are going to be used on the discovery stage. And we do the same as we go through the life cycle. So on discovery stage or phase, the objective of this phase is actually to bring our customer experience matters in telecoms company, as well as to also map to reduce potential use of used to the test the hypothesis that would be proposed. A collection of technologies and tools being used would be voluminous data in different structures. There's also this stage will be to show how big data analytics differs from prior art such as data warehousing and statistical methods in terms of capabilities of uncovering insights from large volume data sets. Then the team members, we have tabulated the team members and their roles on the discovery stage. We propose that we are going to use 7 groups of team members, namely business users. Their role is assisting with understanding of the domain area, then the project sponsor for provision of resources, then the project manager that is being instrumental in ensuring that the project objectives are achieved, then the data scientist provides analytics techniques and modeling capabilities, expertise, database administrator, creating the database environment, then business intelligence analysts providing telecoms data expertise based on deep understanding of the data, as well as data engineers providing subject matter expertise and assist with the data management and extraction, as well as supporting the creation of the analytic sandboxes, providing analytical techniques on data modeling, applying valid analytical techniques to give business problems, and ensuring overall analytical objectives that are made. Then we come to the tools. On this one, big data analysis use cases will include channel analysis, prediction, product recommendation, and the proactive customer cares. Then also there will be also use of network KPIs so that to understand and gather more insights into user quality of experience, which will be put into tests. Then the data sources will include budget will be drafted to determine the financial support needed for the successful completion of the project, and also scope of the work will be defined. Then the telecom companies in question naturally will be having big data, and the consultants will not only have to handle structured data, but also semi-structured data, and mostly unstructured data as well. So on this one, we have tried to actually implement the OTTD, that is the objectives, the team members and their roles, then the tools and the data source. Then we'll also try to implement the second phase, which is data preparation. On data preparation, the objective of this phase will be actually to ensure that all the information requirements are available. Then also to collect and process and clean, as well as normalizing the accumulated data or information. This is the objective technique which is going to be used under data preparation. Then team members and their roles, that is the data analysts, will be required here to manipulate, extract, and manipulate data to derive insights that create business value. Then also data scientists to extract, cleanse, and pre-process the data and build visualization to derive insights to unlock business value. Then data management administrators, database management administrators will also be required in designing the database and maintaining data integrity. Then the data engineer again will be required again in building the system for collecting, validating, and preparing data and deployment of the machine learning models, since we are at what? Data preparation, right? Then on this one, the tools to be used, we have selected R and Python as tools to be used for descriptive statistics and visualization to identify key variables to help categorize the data, right? Then data sources for this one actually includes on the data sources on this one, very deep, but we have mentioned the issue of ELT, right? execute, load, and transform, to perform, to get data into the sandbox, for data transformation and cleansing, SQL, then Hadoop, and Mapreduce and Alpine Miner will be actually used as tools on this one. So here we've included both the data sources and the tools on one stage. Then on phase 3, which is the model planning. The model planning objective of this phase will be refining an analytic plan after the peer review, as well as exploring data to learn about relationships between variables. Then team members, data scientists, and then consultants, and then DBAs to perform ETL and design the schema. As we are seeing, as we are going down here, some of the data, some of the team members, we are now reducing them so that they will be actually suiting the stage which we are now applying for. Then we come to data sources for phase 3, which is modeling and planning, model planning. The sources of the data, subsequently key variables and the most suitable models are selected. Inputs from stakeholders and telecom domain experts will be considered. Iterative testing to confirm most significant variables to be done, considering the nature of the data available for telecoms. Right? On this one, on this stage, actually there will be steps which will be involved in the data exploration, with data identification, univariate analysis, multivariate analysis, filling now values, and feature engineering. Since we are at what? At model planning. Right. Then it will take us actually to phase 4, where there is model building. On model building, the model is the building is the process where we are to deploy the planned model into a real-time environment. It allows the analysis to solidify their decision-making process by gaining in-depth analytics information. This is a repetitive process as it involves adding new features as required by your customers.
Sorry, just a moment. Miriam, may you kindly mute? Miriam Maira.
Okay, thank you. So on this phase of model building, we are going to apply again the OTD, which is the objectives, team members and their roles, then the tools and the data sources on this one, right? On the objectives for data modeling is to make a model data, is to ensure that the model data is sufficiently robust and analytical techniques are employed. Then to develop and make data sets for testing, training, and production processes, which is the objective of this stage. Then the team members are to be involved. This includes the data scientists and the data engineers, right? If you are following closely, you discover that from our first phase, we were having the stakeholders. Maybe if I can just maybe show you here, we're having the business users, sponsors, and the like, including the data engineers as well as the DBA. But as we are now going down here, we are now shifting and reducing the number to more specialistic team members. Here is actually the role of the data scientists and data engineers alone on this phase, which is the model building, right? Then on the tools which are going to be used, we have selected R and Python, which will be the main tools for the development of the model. And the team will also consider whether its existing tools will suffice for running the model, or if they need more robust environment for executing the model. Right? The team will strive to get the best environment for the model and workflows. This includes fast hardware with computing power. Right? On the data source, we failed actually to find where exactly we're going to take any additional data, but we discovered that it will be taken from the pool of the data which we've already been working with from our phase 3, which we have been gathered and which we are building. So we are now taking it from there. So we have been silent on the data source on this model, on this stage or phase. Then phase 5 is now communicating what? Results. The results will be communicated by data visualization tools. This is because the data visualization presents data in a visual context, which makes it easier for people to understand, right? Objective of this phase includes evaluating the outcome of the results in terms of success and failure and assessing them statistically. Then the second one is preparing presentation for all stakeholders, expressing insights from the findings as well as the monetary value or project's obstacles and proposed solutions. On the team members on communication of results, we were having a lot of discussions about this, whereby we were saying who is going to communicate the results. Are they the users or the data analysts or scientists? So Tazosia Pari Blank, we hope that you are going to assist us also on this one. I'll highlight it as ready. Then on tools, we talked about network diagrams and then clustered bar graphs and word clouds, right? Then the data sources is data output from the model, which we've been used for results expressions. Then the last phase, which is actually operationalization, right? The objective of this phase is to provide detailed report with findings, coding, briefings, technical papers, and documents to stakeholders. To run a pilot or prototypes, that is the model execution in production environment. It's like now we are now deploying the model, which we have actually modeled in phase 4 into a live environment. Then the team members or roles includes business users, project sponsors, project managers, business intelligence analysts, engineers, and database administrators, right? As you are seeing here, we are now bringing all those members which we have introduced at our first phase in our discovery phase, at the last phase, so that they validate whatever we have deployed and also evaluate if we have met the results or objectives we have been set from start at the discovery phase. Then the tools here include the statistical, mathematical, and visual softwares which will be used, systems to log errors into systems, environments, and datasets will be set up for model and business improvements. The data source is mentioned in the case study that some of the models are able to detect service outage faster than call centers by extracting the data from social media platforms, analyzing tweets with network topologies. The findings can therefore be used to enhance mechanisms needed to continually reevaluate the model after deployment to ensure that the model is maintaining a predetermined desired level of performance. Then in our presentation, we put a conclusion, which was trying to sum up from first phase up to the last phase, just as a descriptive. Thank you. I think my presentation ends here. But what I was trying to emphasize is how exactly we can apply the BGL to any case study, which we have been given in the question. Thank you. I submit, Chair.
Thank you, Jeremiah, for that. It was well presented. Any questions, Tim? Additions, subtractions?
Jeremiah, have you shared your document?
So far, it's just with my team members. We haven't shared. I think we are going to send it to who is consolidating. Maybe on the screen. It's okay. I'll share it on the group.
Noted.
All right. With that, we move on to part 2 of the question. This was to be presented by Nyari. Last I checked, she said she was joining shortly, but she'd sent some links to a few documents. Then there is also Dr. Mike and Primi. Anyone presenting, guys, from Dr. Mike and Primi, and probably if Nyari is now in. Okay, since there's no response
Hello, guys.
from... Okay. Hi, Nyari, you can go ahead.
Hi, sorry for the delay. Hey, I'm working on a tight schedule, Saka. But I just found something. Chinobatsira kuita differentiate the roles. Then I'm sure apa vakati telecoms, but I think it cuts across different industries. So pane the first one, rakanzi masters in datascience.org. If you open it, if you go down, they have outlined the different roles for data analyst and data scientists. And I'll just read through. For the data analyst, they said data querying using SQL.
Sorry, Nyari.
Data analysis, yes.
Sorry, Nyari. Are you able to share your screen?
I'm using a mobile phone.
All right.
But
okay.
I have shared the link in the group. Let
Okay,
me try.
all right.
Can
That's
you
fine.
share the screen? Okay. Let me just try. You are sharing your screen. Marcus, when I'm my picture edu manje.
Okay. All I can see is an ITEL.
Then I tell. All right. Can you see something?
Yes, sure.
All right. So upper they've outlined the roles, data analyst and data scientist. So for the analyst, they say data querying using SQL, data analysis and forecasting. Of course, it might not be SQL only. It could be other forms of querying. Data analysis using Excel, creating dashboards using business intelligence softwares, Tableau, Power BI, then performing various types of analytics, including descriptive, diagnostic, predictive, or prescriptive analytics. I'm sure you can all differentiate between descriptive, diagnostics, and predictive. Then for the data scientists, they spend up to 60% of their time scrubbing data. By scrubbing, I'm not sure, does it mean cleaning or it has a different meaning? Then data mining using APIs or ETL pipelines, data cleaning using programming languages, statistical analysis using machine learning, creating programming and automation techniques such as libraries that simplify day-to-day processes using tools like TensorFlow to develop and train machine learning models, developing big data infrastructures using Hadoop and Spark tools such as Pig and Hive. Yeah, so from this, I don't know the words to really differentiate this, but it seems like the data analysts, they are mostly concerned with preparing data to present it maybe to the people vanenge vachida kupresenterwa data, be it the directorate or something like that. Zvandiri kuona kuti theirs is like working with the data rinenge raklinwa for visualization and making sense out of the data, and just they vanongomirira pa-analytics, just analyzing the data. Then the data scientist ndo vanoona nezve maybe the software involved and machine learning stuff. Yeah, ndo zviri papa. I may not if there are any additions. Then let me check the other. Is there anything?
Okay, thanks. While you are checking, Nyari, thank you very much. Our presenter story right, Chaizo. The word scientist, link it to experiments, and analyst analyzing the data actually to derive predictive insights and the explorative meaning. Scientist, science for experiment, analyst analyzing whatever chatwapo. Thank you.
Thanks so much. Then I think Pasara, one of them. Let me look at the question paper. Pangapaganzi, the role of the kunenge kwasara, the big data analyst. Yeah, ndiye wandashaya kuti difference yake iri papi.
I have sent something on group. I think it may help.
Okay, Penny, okay. Penny against my roles. Let me just open the document.
I think Nyari was put out of the meeting. That one Ati left. Primi and can you finish off? Okay.
Hi guys.
Hi Primrose.
I'm sorry, that's not we had to prepare. I just had a hectic day. So I'm just trying to go through assignment here. Takaito last time. I just wanted to check if I can get and Papa Sarapati big data analyst, auntie.
Yeah.
Okay, just a second.
Okay. In the meantime, for our next presenters, Elizabeth Cliff and Gauss Makov, just get ready to present after Primrose has concluded.
Okay, can you guys see my screen now?
Yes, sure.
Okay, so I'm gonna get you guys and go through assignment together. I hadn't prepared much. So the roles of a big data analyst. Okay, I'll just read through what I have. Okay. The responsibility of a big data professional lies around dealing with huge amounts of heterogeneous data, which is gathered from various sources coming in at high velocity. Let me just go through the roles of a big data analyst. The roles are to gather and accumulate data from disparate sources, clean it, organize it, and process it, and analyze it to extract valuable insights and information. Another role is to also identify new sources of data and develop methods to improve data mining, analysis, and reporting. Another role is also to write SQL queries to extract data from the data warehouse. Then to create data definitions for new database files or alterations made to the already existing ones for analysis purposes. Then another role is to also present the findings in reports, that is in table, charts, or graph format to help the management team in the decision-making process. Then another one is to develop relational databases for sourcing and collecting data. Then to monitor the performance of data mining systems and fix issues if there are any. Then to also apply statistical analysis methods for consumer data research and analysis purposes. To keep track of the trends and correlational patterns among complex data sets. To perform routine analysis tasks to support day-to-day business functioning and decision-making. Then to also collaborate with data scientists to develop innovative analytic tools. Then lastly, to work in close collaboration with both the IT team and the business management team to accomplish company goals. So I think these are the roles of the big data analyst. So I think it's just right. It's just sorry guys. Sorry. Okay. Sorry guys. Ndanga ndiri ndisinga zvanga zvisiri kuoneka. Hello guys.
Okay, yeah, it's really a little bit small font. Maybe since you are going to share in the group, probably fine.
Okay. Sorry guys. Ndanga ndisina kuona kuti font yanga iri a bit smaller. So right. So I think I can just share the document in the group as well, if it's okay. So I just saying overall the responsibility of a big data professional, it just lies around dealing with huge amounts of heterogeneous data which is gathered from various sources coming in at high velocity. So I'll share the document in the group. Thank you guys.
Hello, just to thank you, Prim, for that. Just to also maybe come in as well. Like our question is asking specifically for telecoms. So in summary, I think the role of my data analysts is to collect the data, then consolidate it, to consolidate the same data that you have collected, to integrate data as well. I'm just trying to summarize. Then we go on to processing and interpretation of the data, which also leads to data visualization. Then after that, we're now talking of decision making and also performance measurement. So basically, that's how that's the role of my big data analyst in a telecom industry setup, where they are supposed to be collecting data. It may be competition data, or maybe usage data, which they now consolidate and also integrate, analyze, interpret, and use that data for decision making, or for performance management, or for performance improvement. Thank you.
Thank you, Michael. Okay. Any contributions, additions, subtractions? Otherwise, we can move on to the next next team.
Yes, Angel. I think Tanga Siri Rapid like Chataronzi is in a telecoms company, so maybe it's important to I think I will write it again, Jakanak. Nikawana time and repost the answer. So articulate which kind of data in the telecoms industry, because we can have network equipment data whereby network analysis, network, the kind of information in networks. You can have even inventory data, but in making some business investment decisions. We can have customer data, we can have call data records, we can have even usage data, product analysis, we can have that data. We can also have even employee data, something like that. So I think the other trick is to just to write the exact kind of data that can be found in a telecoms industry. Thank you.
Okay, Nyari, we'll wait for the updated document. If there's nothing more to add or subtract, I think we go on to the next team. Elizabeth gave an excuse. She wasn't able to prepare. The rest of the team, Gauss and Cliff, hopefully had prepared something for us. All right. Okay. We move on to the next question since Wangwasna ku responda. Oxy and team, Jack Jackson.
To go through some kind of transition as
Oxy and Jack Jackson. Who's the other one?
Spain, Germany, Italy, even England, through those transitions. France team without Maria Giroud again.
And Ruimbo.
It's the end of an era, isn't it, really?
Okay, I sent something to Auxilia to do to consolidate. So let me get in touch with her and get maybe what is it that we need to prepare something which we can share in the group. But what we just need to do is now to check with Auxilia if that okay.
All right, that's fine. That's fine. We can move on to the next group while you get your stuff in order.
Okay.
The next group, I think this should be question 2 now.
It's outrageous play all around. First of all, Lukaku, the strength to hold off the defenders and then get the ball in. But
Ngoni, Carol, and Fadzi to take us through question 2.
Hello, colleagues.
Hi, Fadzi.
I will take you through what we've prepared on question 2A. So I'll just share my screen. Yeah. Can you see my screen?
Yes, Patsy.
Okay. So the question was using a well-labeled diagram, explain the Mapreduce paradigm. The diagram that I'm going to be using is this one, the diagram for the Mapreduce architecture. So Mapreduce paradigm is the Mapreduce is a programming paradigm that was designed to allow parallel distributed processing of large sets of data, converting them to sets of tuples and then combining and reducing those tuples into smaller sets of tuples. So tuples, I think we all understand that they are rows, right? And then Mapreduce was designed to take big data and use distributed computing to turn big data into little or regular size data. So we understand, like, when we are in the Hadoop file system, that we are working with very big data sets. So the Mapreduce paradigm, it is the one which is now used to turn those big data sets into regular size or into smaller, manageable data sets. So it uses a parallel distributed processing, which refers to a powerful framework where mass volume of data are processed very quickly by distributing processing tasks across clusters of commodity servers. With respect to Mapreduce, tuples refer to key value pairs by which data is grouped, sorted, and processed. In the map task, you delegate your data to key value pairs, transform it, and filter it. Then you assign the data to nodes for processing. So in the Mapreduce, it is like two processes which are just combined together. There's mapping and reducing. So you have a big data set. It has to be mapped first, and then it will be reduced. So the mapping of the data, the incoming data must first be delegated into key value pairs and divided into fragments, which are then assigned to map tasks. So from our diagram, we have this first part, the blue part, which is stacked together. These are the big data sets that we are receiving, and those are big data sets. They are now reduced into small packets, which are now those blue, green, yellow ones. So they'll be assigned to map tasks. Each computing cluster, a group of nodes that are connected to each other and perform a shared computing task, is assigned a number of map tasks which are subsequently distributed among its nodes. Upon processing of the key value pairs, intermediate key value pairs are generated. So the key value pairs, they are generated. You can see that there are connections between this second batch of tasks with the next ones. And you can see that the arrows, they are pointing from each point to the other cluster in front of them. So those are connections which are now is done in the mapping process. So upon processing the key value pairs, upon processing of the key value pairs, intermediate key value pairs are generated. The intermediate key value pairs are sorted by their key values, and this list is divided into a new set of fragments. Whatever count you have for these new fragments, it will be the same as the count of the reduced tasks. So after the mapping process is finished, we now going to go to the reduced task. In the reduced task, you aggregate that data down to smaller sized data sets. Data from the reduced step is transformed into a standard key format where the key acts as the record identifier, and the value is the value that's being identified by the key. The clusters computing nodes process the map and registers that are defined by the user. So these are the next one. This reduce the data is the same explanation as we have above. In short, you can quickly and efficiently boil down and begin to make sense of huge volume, velocity, and variety of data by using map and registers to tag your data by key value pairs, and then reduce those pairs into smaller sets of data through aggregation operations. Operations that combine multiple values from a data set into a single value. So you can see the point of reducing, and now we'll be having all the big data will be now compressed in one database. So the search phase is geared towards throughput as it processes very efficiently large batches of queries, typically at 10 to the power 4 or 10 to the power 7 query descriptors. The search also requires a preliminary step, the creation of a lookup table where all query descriptors of a batch are grouped according to their closest representative discovered from the transversing and index tree. This lookup table is written to the local disk of the nodes that will perform the search. Each map task receives a block of data from one of the previously created index files, and the second thing is the file containing the lookup table. The mapper processes only the descriptors in its assigned chunk of data, which are relevant for the queries. Distance calculations are computed for those descriptors and queries assigned to the same cluster identifier. And then the KN results are eventually emitted by the mappers and then aggregated by reducers to create the final result for the query batch. So if your data doesn't lend itself to being tagged and processed via keys and values and aggregation, then the map and reduce generally is not the good fit for your data. So you find that if you cannot find the keys to identify your data and the values for your data, you cannot use the Mapreduce paradigm. So if you are using Mapreduce as part of a Hadoop solution, then the final output is written onto the Hadoop distributed file system, HDFS. HDFS is a file system that includes clusters of commodity servers that are used to store big data. HDFS makes big data handling and storage financially feasible by distributing storage tasks across clusters of cheap commodity servers. So map and reduce functions do not address the parallelization and execution of the Mapreduce jobs. This is the responsibility of the Mapreduce model, which automatically takes care of distribution of input data as well as scheduling and managing map and reduce tasks. I just brought this part because it brings a bit of confusion when you're saying Mapreduce paradigm and Mapreduce parallelization. So I just needed so that we have a clear demarcation between these two processes. I think that's all that we have on Mapreduce paradigm. Thank you.
Thank you, Fadzi. Guys, questions, contributions? Vanesha kuwedzera. Okay, I'll take.
The question, Angel.
Go ahead, Ishmael.
In the previous, if I'm not mistaken, in the previous group presentations, pane chimwe diagram chakaiswa nerimwe group, so chisina kunyatsofanana nechapresentwa ichi, asi chinenge chiri cheMapreduce chakanzi munofanira kuchiziva. Ndechipi ichocho kana kuti ndeche different person altogether? Maybe someone can help.
Okay, Ishmael, I noted. It was actually our group which was presenting about Hadoop file system, whereby we mentioned about the issue of Mapreduce, and the diagram is there, but it was under ethical. It's ethical hacking, not big data.
Saka zvakuvhiringa manje. Ingeri ethical hacking. It's big data. Remember, this diagram saregere kuriziva because it's coming or something. I'll check again the recording. Thank you for that.
It was actually big data. Remember, you should know Mapreduce and the steps that you go through. I think the diagram map. Then in between there was a section on the shift and sorting area, something like that. Yeah, guys, in sort of like my big bracket. So, and at the end there was the reduce, if I'm not mistaken, in a column. Ma totals. So
Yeah, maybe if I, sorry.
Hello, Kero. Kero, I hope you're not speaking to a muted mic.
Oh, sorry, Angel. I had Ndanda Kumbo manager sound on my side. Okay. I wanted to just support what you were saying, to say maybe if, that diagram that you are referring to, it's there in our slides. Maybe just to highlight that it's basically the same thing with what we have presented, or with what Fadai has presented, because the basic idea there is the map side and the reduce side. So when we are saying we have our big data sets, that's the input data, and then we split the data after that into small chunks, and then that data is then mapped into what is referred to as sort and send, or some say sort and some say shuffle and sort, and then that is then made. That's where the data is then assigned values, the key value and the key and the value. Each item is assigned a key and a value. Then after that, the data is merged. So there's also, from another website, there's an example, a word count example, whereby, for instance, in the data input, you've got words that also that duplicate. So on the map, or where we are then sorting or shuffling, that's where, after those keys have been assigned, and by default they assigned key 1, then at the end where we are saying we are now merging, or where we are reducing, we want to be able to achieve, to say maybe in the input data we had some duplications on car, or maybe on certain data that is duplicated. We, instead of saying car, we just then end up saying car is appearing 3 times. So we have car 3 in our final output. So that is the element of reducing from the big chunk of data where we are repeating the same word that is in a data set, to just mentioning the word once, and then we highlight how many times it's appearing. Thank you.
Thank you for that, Kero. I think that's the same with what Jeremiah is sharing there.
Draw diagram gradually.
Now, as we can see, the pectanga papakanzi mepa input and it.
I'm
So you
coming.
can mute your mic. Can you mute your mic? Okay. So I think pectanga papakanzi mepa input, where we have that sentence you up and it, the cat set on the mat. Then it goes through to the mapping section, whereby we are counting the number of words in each. We are counting the number of words. We are picking the number of words in the sentence. The first word, the set, tungo to 111 on each, and it. Then we go to the shuffling part, whereby we're putting similar words in whereby we're putting similar words in the same group, and did it. At the bottom there, corner the word is appearing 1, 2, 3, 4 times, but the counts. Then we're going to the reduce part. Then we're saying the is appearing 4 times, just like what Kira was saying. Then we have the final result, whereby we're saying the is 4 times, set 2 times, cat 1 time, met 1 time, and that other one, I'm not so sure, 1 time. So that is the final result, where we have the mapping, mapper input, mapping, shuffling, reducing, and final result.
Thank you. Actually, when they say the steps, those are the steps which you are talking about. The mapper input, mapping, shuffling, reducing, and final results. Thank you.
All right. It seems Jeremiah has been put it out there, so it's fine. If there are no questions or further additions, we can move on to the next team that are presenting question 2, part B.
Hi, Angel.
Hi.
Can I please present question 4, one part, question 4?
This is Ruimbo, right?
Yes, it's Ruimbo.
Okay, you can go ahead, Ruimbo, whilst the other team is preparing. So Ruimbo is presenting question 1, part 4. You can go ahead, Ruimbo.
I sent through the document that we worked on WhatsApp. I'm sorry I cannot share my screen. I'm using my phone. Inejipande. The question reads, use a 4-quadrant regression model to classify how big data can be used to improve the quality of experience in telecoms. So we started by defining the quality of experience, whereby we started by defining the quality of experience is the degree of delight or frustration experienced by a user of an application or service. It is an outcome of the application or service meeting the user's expectations in terms of usefulness or enjoyment, considering the user's personality and the present condition, right? And then we moved on to a variety of variables that can influence the characteristics of the service provided by the mobile network operators, such as the system, human background, and education. And then we moved on. So in general, a service related with the quality of experience, with the quality of experience is measured by the value of the mean opinion score, which indicates a user's subjective experience with a given network. So we then moved on and we talked about, I don't know if it's the right thing, but we moved and we talked about data collection. These are the stages, right? For the 4-quadrant. Data collection, data processing, predictive analytics, prescriptive analytics. And then we started looking on data collection. So data collection. So in big data, it involves the collection and processing of huge quality of data, which are omnipresent and has the capacity to change fast over time. So telecom operators are considerably more interested in the data-driven choices to deal with the interruptions as shown in the network performance, and gives an ideal solution
users of the federated databases, they do not need to know about the schemas of all components, but only about the federated schema. Users of this system must rely on the translation mechanism. So if you look at the diagram, it's not very clear again, but I will try to get a clearer one. You can see that the mediator-based information system consists of components that use independent processes to construct and publicize an integrated federated database. So as you can see, this is the MBIS architecture. The federation layer. Okay. The federation layer contains several mediators providing mediation services. Hence, it is called the mediation layer. Then we have each mediator is its own federated schema, and mediators can use other mediators as data sources. Wrappers hide technical data model heterogeneity, and queries against federated schemas are dotted, while queries against source queries are lines. So you can see these are the queries with dotted lines, and these are the queries with solid lines. So I'll find a clearer picture that can that is more that you can use it when I post the whole presentation. I submit.
Thank you, Dananai. Ladies and gentlemen, questions, addition, subtraction.
Okay, thank you for the nice presentation. Maybe just to add there, we have to add issues such as distribution, heterogeneity, autonomy, and networking. Those are the 4 dimensions or elements which are used or to describe or characterize these issues of federated databases. Of course, you have mentioned the 2 types, which is the loosely coupled and the tightly coupled. But in describing those ones, we will be using the 4 elements, that is distribution, heterogeneity, autonomy, and dimension. Probably she have managed to articulate those ones, but maybe I was not listening in terms of network. Thank you.
Okay. Thank you, Jeremiah.
All right. Thank you, Jeremiah. Moving on, if there are no further questions, the next team is comprised of Moses, Ernest, Welly, and Felicity.
Hi, guys.
Hi, Welly.
I'm sorry we didn't manage to coordinate ourselves. I only communicated na Felicity. So ndisingazivi kuti vanoitwa Moses na Ernest vari kupi. Hanangombonge ndataura navo. If they have something changa vakaprepare, it's fine, but kana vasina we can present zvatangataita na Felicity. So kindly Moses and Ernest confirm if they have anything, if they have something for the group.
In the interest of time, Welly, I think you can go ahead and present. If there's anything that you have left out, they can always chip in and give us the additions. And probably if there are any questions, they'll also address the questions as well.
Okay, thank you. But in this case, I will only share my screen and Felicity will do the rest.
Noted.
It's coming. Are you able to see the screen?
Yes.
So Felicity, over to you.
Good evening, everyone. I'm presenting on question 3C, which is explaining the architecture of the Hadoop distributed file system with the aid of a diagram. So we can see the diagram which is beamed on the screen there. So in a HDFS, the architecture basically follows the master-slave architecture in the cluster. The system having the name node acts as the master server, and it performs quite a number of tasks, which are maintaining and managing the data nodes or the slave nodes, if you can call them that. It also records the metadata of the files stored in the clusters. For example, the location of the blocks stored, the size of the files, the permissions, the hierarchy, etc. There are two files associated with the metadata, which are the FS image. It contains the complete state of the file system namespace. And we have also the edit logs, which contain all the recent modifications made to the file system with respect to the most recent FS image. So the name node also records each change that takes place to the file system metadata. For example, if a file is deleted, then the name node will immediately record this in the edit log. It also regularly receives a heartbeat and a block report from all the data nodes in the cluster to ensure that the data nodes are live. The name node also keeps a record of all the blocks in the HDFS, and it is also responsible of taking care of the replication factor of all the blocks. So whenever a client wants to write information to the HDFS or read information from the HDFS, it connects with the name node, and then the name node returns the location of the blocks to the client, and the operation is carried out. We also have the data node in the HDFS. So the data nodes are the worker nodes, and the data nodes manage the data storage of their system.
They perform the read-write operations on the file systems as per the client requests. They also perform operations such as block creation, deletion, and replication according to the instructions of the name node. So we have the secondary name nodes. The secondary name node works concurrently with the primary name node as a helper. And let's say, suppose we need to restart the name node, which can happen in a case of failure. This would mean that we have to copy the FS image from the disk memory. Also have to copy the latest copy to the latest copy of the edit log to the FS image to keep track of all the transactions. But then if we restart the node after a long time, then the edit log would have grown in size, and it would take a lot of time to apply the transitions from the edit log. And during this time, the file system would be offline. So to solve the problem, we bring in the secondary name node. But however, the secondary name node does not act as a name node. It's merely for checkpointing and keeping a copy of the latest FS image. We have also what we call the block. So generally the user data is stored in the files of the HDFS, and the files would be divided into one or more segments and stored in individual data nodes. So these segments are called the blocks. We can see the blocks in the diagram. I think it's mentioned if you go back to the diagram. So the default block size is 64 megabytes, but it can be increased as per the need to change in the HDFS configuration. So I think I'll just quickly skip to the HDFS read and write architecture, where the write operation when a client wants to write a file to the HDFS, it communicates to the name node for metadata. And then the name node responds with a number of blocks, their location, replicas, and other details. And based on the information from the name node, the client directly interacts with the data node. The client first sends block A to data node 1 along with the IP of the other two data nodes where replicas will be stored. And when data node 1 receives block A from the client, the data node 1 copies the same block to the data node 2 of the same network, as both the data nodes are in the same rack. So block transfer via rack switch. Now the data node 2 copies the same block to data node 4 on a different rack. Yes, but the data nodes are in different racks, so block transfer via an out of rack switch. When the data node receives the blocks from the client, it sends write confirmation to the name node, and the same process is repeated for each block of the file. And as for the read operation, to read from HDFS, the client first communicates with the name node for metadata, and the name node responds with the locations of the locations. The client then directly interacts with the data nodes. The client starts reading the data parallelly from the data nodes based on the information received from the name node, and the data will flow directly from the data node to the client. So when a client or application receives all the blocks of the file, it combines these blocks into the form of an original file. I think that's what we had for question 3C.
Thank you, Welly and Feli. Any questions, guys? Additions?
Maybe just to check, Angel. Memo wakati ne Hadoop wakati ndezvipi zviri kuuya ipapa kuti nyatso concentrate nekuti inenge yakati kurei.
One thing that I managed to pick up was how you could know the Hadoop ecosystem. This thing as if I missed anything else, but I managed to pick that up.
Okay, saka Hadoop ecosystem ne Hadoop file system zvakasiyana.
Yes, issue.
Hello, okay.
Hadoop ecosystem, it's like an environment where the Hadoop file distributed system, HDFS, also exists. And inside there are also an Mapreduce, banani imomo mukati momo. Saka the ecosystem is broader than the HDFS. That's what I've seen. I'm not sure if I'm correct.
Hadoop papa. If you still remember that question, takamboita yaida big data analyst, big data life cycle. Yakaunzwa naMomso yakanzi using the Hadoop. Unenge wakuita sei ivavo manje? Kasindrindega pana.
Ewa usiwega.
Watsenga mkano wa maika tinozvinzwa izvo.
Funny, if you still remember correctly, it should one of the assignments yatakaita yaMomso should be group. It was just it was asking on the big data life cycle. But yakanzi, sorry, computer yangu iri kunonoka kustart, but I would have read the question. But yanga ikaisa ka case study, just like what we did earlier. Then your Bayazoti explained the big data analyst, big data life cycle using the Hadoop ecosystem. Apana na last assignment.
Okay, I think it's the first one here, Taita, and here telecoms industry. What? Huh? Gio?
Yeah.
No. No, it's not the one.
because you yanga yakatonyora kuti using the Hadoop file system. No, it's not this one.
Mike ukaiona kuti noti iyo emandauzo andangobva ndasangana neyakadaro yaizotichiita Hadoop ndikadai ndakatofenda ipapo.
Mike, I think wakaresa kuverenga. The assignment yaitwa present one has the case study. The issue of Hadoop, where it came from. Question 1A, there has been much hype about big data analytics, a collection of technologies, including the Hadoop distributed file system, NoSQL databases, what. Maybe ndopa wakangobata pekuti pane issue of Hadoop, then nobazolinga kuti apply BD. Maybe that's what I'm thinking. Unless kana iriko right, but ndofunga nti waona this yakaita nasi.
No, it's okay. Let me just check the question. Then.
All right, Mike, can you please present the slide yangeni the Hadoop ecosystem here?
No, it's someone anga present. It's not me.
It's not you. Oh, okay. Because
okay. Sorry, Angel.
Go ahead.
Yeah, I just wanted to say, can I see Hadoop ecosystem? It's like a collection of applications anoshandamu within the Hadoop ecosystem. So in that ecosystem, doma unowana wana HDFS, doma unowana wana Zookeeper, wana Mapreduce, wana Uzi. So my applications are esaning perform different activities within that. So it's an ecosystem. Like a environmental ecosystem where you find there are a lot of animals which interdepend on each other. So animals, I take them to the applications which are working together towards refining the data that they are getting from different sources. So each and every application within that ecosystem will be performing a specific task towards so that at the end you get value from the data, the structured and all the types of data that we are getting. I don't know, Ishmael, if you managed to understand what I'm saying.
Yes, I'm getting it. Where I wanted to be very confused now was to link the Hadoop system to the big data lifecycle. If anyone can assist if there is any link, but if it doesn't, then I'm okay.
HDFS, it's mostly for data storage. Saka kana tiri ku big data inondopinda kana takutsvaga zvinhu zve storage of data within our big data life cycle. Because ndo basa rayo mu ecosystem, Hadoop ecosystem, it's mainly for storage, for data storage.
Thank you.
All right. To build on to what Fad was just...
Sorry, come again for question. Yeah, noise.
All right. Ndokumbira kuti anga achipresent akaite reshare their screen. Sorry. Because zvimwe zvacho na unoita you see.
Sorry, what I was saying is Hadoop ecosystem, it's a collection of my applications. And it is akasiyana. My applications are anoita different tasks. Saka HDFS, basa rayo kazhinji kana iri Hadoop ecosystem is for storage purposes. Like Zookeeper is there for coordination. And it is Vana Mapreduce is there to inotora data sets anounza information yakawanda and then it reduces, so it's like compressing the information. And is vana pane databases inenge ichi mano SQL inenge ichikwanisa ku organize and organize the data and data risiri organized area. So that kind of a database inenge ichikwanisa ku arrange information yedu inenge isiri structured and it's unstructured data. So each and every application within the Hadoop ecosystem in a specific task. And saka HDFS, mostly it is for storage purposes. If you try to get panema diagrams, the picture I show you
Hello.
show ma different tasks for each and every one hive, one pig. We say one different tasks that we are doing. So you just have to know it will be easy for you to understand that. I don't know if I managed to answer you.
Hello, Fadzi.
Yes.
Alright, ndachida kuti patinotaura nezvekuti HDF mapurpose yawo nde I think the most important patichitaura issue yacho ndezvekuti create ma nodes handiti atinonge tichiisa like tikuti purpose yestorage iyi ndeyekuti tisarase information handiti. So information iya isarasike kana tikange tiine we create blocks handiti to information to distribute let's say last time when I presented tikati tine 600 megabytes of data handiti tinoisplita handiti we are supposed to create blocks edu. You say the default one is 128 megabytes handiti. So if it's 600, then you 128, 128, 128, and then the remaining 88 so at the end of mu block radzo. Purpose yekuita izvi ndeyekuti data redu risarasike, because data redu tichida kuti run away from data rinorasika, and takabva tataura tikati panobva pacreatika replica files inenge saka the replication method iyoyo inobva yaita kuti kana information ikarasika in one tinobva tanoiwana in the other. That's why I just wanted to add.
Okay, thank you so much, Fadzi and Oxy. I'll share a bit of my understanding of the ecosystem. Mukatarisisa hapo those three parts, the HDFS, the yarn, and the Mapreduce, those are the main components of the Hadoop file system. Then zvimwe are additions on to the file system. Achishanda zvakasiyana siyana. Like for Mapreduce, you find we have pig and hive sitting on top of them. Iwayo anoita basa rakada kufanana neMapreduce, whereby we're saying kuti hive, it looks for information and it within the Hadoop file system, and it using for vanenge vajaira kuita is it SQL, so you can structure your queries using hive and to look for your data. Alternatively, you can use pig. It just says it all comes under Mapreduce as way of extracting your data as you're using it. Then patrokutaura kuti data redu. Now we are linking it to the big data lifecycle. We are saying kuti data redu rinoya in various forms and structured and unstructured, semi-structured. We have that part pedzira yakanzi data ingestion, whereby panema components 3 aripo: Flume, Kafka, and Scoop. And anobatsira to store that data. Anomutoona kuti pakaenderana neHDFS app kuti it gets that data and helps in storing it within our Hadoop file system. The same goes for all other components in the repo. Each has a different function. What I'll do is I'll try to share a YouTube video which was explaining this diagram as it is. It will help you get a better understanding of the ecosystem. Then Pamsoro app, we have Ambari, whereby we're saying it oversees everything now. And from it, you're able to see is Zookeeper working well, is Uzi working well, whatever other bits you have added into your Hadoop ecosystem. And you're also able to do some other applications from the Apache Ambari. So I think that video and but I'll try to look for it and share per group.
Thank you. You have fought a big battle, Fadzi, Angela, Auxilia. Hey, ladies, akomana vari kubatsira.
Wete Shumairi.
Kweninda brother, inda wapamurume. Tinda kuzichi.
All right. I think we can move on to the next group that is supposed to present. Question 4. Tino Malvin, Kudakwashe Moyo, Tinashe Marume, question 4A, part 1. Gentlemen, are you in the house?
Angel, if they are not there, can I present on 2C?
Thank you so much, Tapio and Aisha. You can go ahead.
Okay, let me share my screen. Okay, can you see my screen now?
Yes.
Okay. All right, the question is explain the CAP theorem and best properties of NoSQL databases. So the CAP theorem is a belief from theoretical computer science about distributed data stores that claims in the event of a network failure on a distributed database, it is possible to provide either consistency or availability, but not both. So let's say network failure on a distributed database or in our NoSQL database. Consistency or availability are actually guaranteed, but not both. You can't have both C and A. So CAP is for consistency, availability, then partition tolerance. So the CAP theorem is comprised of these three components: consistency, where we say all reads receive the most recent write or an error. Then on availability is all reads contain data, but it might not be the most recent. Then partition tolerance, the system continues to operate despite network failures, dropped partitions, slow network connections, or unavailable network connections between nodes. But you find out that this partition tolerance, the P, is always guaranteed since it's a distributed system. But for consistency and availability, there has to be a trade-off. It has to be either consistency or availability. So in normal operations, your data store provides all three functions. We are saying, normal, everything, network gear up, hardware up, then the CAP is guaranteed. This is no shanda. But now when a distributed database experiences a network failure, you can provide either consistency or availability. So it's a trade-off, like I was saying before. But in the event of a network failure, a choice must be made. So in theorem, partition tolerance is a must, like I said. And the assumption is that the system operates on a distributed data store. So the system by nature operates with network partitions. So when a network failure happens, one can choose to guarantee consistency or availability. So high consistency comes at the cost of low availability. Then high availability comes at the cost of lower consistency. But the P, the partition tolerance, will always be there. So then consistency in this CAP theorem or in CAP is different from the consistency that we have done in ACID properties. Here in CAP, it means having the most up-to-date information. And whilst that in ACID properties, it means that any new transaction to the database won't corrupt the database. The database will always be in a consistent state before and after any transaction. It has to be in a consistent state. But in this CAP, it means it's having the most up-to-date information. Then the second part of the question is you have to explain the best properties of NoSQL databases. So the relational database, they follow the ACID properties, while the NoSQL database follow the BASE, which stands for basically available, soft state, and eventual consistency principles. So the basic availability, it means that the NoSQL database approach focuses on the availability of data, even in the presence of multiple failures. It achieves this by using a highly distributed approach to database management. So instead of maintaining a single large data store and focusing on the fault tolerance of that store, NoSQL database spread data across many storage systems. I'm sure Panama present this is my distributed database or my federal. I'm not sure, but is the thing is data no right across my distributed machines. So there's always a basic availability. So in the unlikely event that a failure disrupts access to a segment of data, this does not necessarily result in a complete database outage. So we have, let's say we have, unlike my relational database, which baby database look about one server. When that server goes down or the hardware goes down, then that's it. We no longer have a database to talk about. But in a distributed database, in my NoSQL database, it will be distributed. So we have some stuff that in it. Then the soft state part, a base system gives up on consistency to improve the performance of the database. So in a static consistency, consistency, you know, is aside at the expense of performance. It is very consistent in your performance could database perform again. So hence most of the famous NoSQL databases are highly available and scalable than ACID compliant relational databases. So soft state in case that the state of the system may change over time, even without input. So consistency is guaranteed. Then the last part is eventual consistency, which the only requirement that NoSQL databases have regarding consistency is to require that at some point in the future, data will converge to a consistent state. So ACID properties, just after transaction, we a consistency state. I mean, database don't consistent state. But in the best properties, NoSQL, we are not really worried about time transactions with even receive consistent database. But after a while, at the end, consistent, which points to the eventual consistency. I think that's it. Any questions?
Yeah, well done, Tapio. I think Tapio wanyatso explainer. I think I might just add on the chingo summarizer what Tapio was saying in terms of my properties, but he explained it very, very well. You'll find some my sources Manongo Marova in point form, but I like the way explainer now. He explained it very well. So in just in nutshell, we are saying my properties of NoSQL, like he mentioned, they said that they have a high scalability, meaning it avoids joins and it is easy to scale, and it is they use distributed computing, meaning multiple NoSQL databases can be executed in a distributed fashion. It's cost effective. It supports flexible schema. they can process both unstructured and semi-structured data. Also in point form, we can say there are no complex relationships such as the ones between tables in a relational database management system. Yeah, just to add on, just to summarize what you were saying, I think.
Yes, for me, thank you very much, Tapia and team, for the clear presentation. But I just wanted a small assistance if you have information, because the question that is coming in the exam is similar to this one, but now it looks at the differences between base properties and the acid. So I just wanted to check if you have got just a little bit on acid. I heard you mentioning it. Thank you.
Come again, Ishi. Sorry, Ishi, come again. You are saying the question which is coming in the exam is about acid.
Yeah, the question is differentiating between acid and base properties. Like the one they tackled, it's shape in relation to base, but the one that is coming has got acid in relation to base. So I just wanted to check if they've got just a little bit of now some notes on acid. Even if they don't, maybe it's for us to go and check for it. Thank you.
Okay, I think we can always go and research that. Thank you for that, Ishmael. But chandaona pa base versus acid is that base inabasa state consistency at a given point in time. Like the acid is a good. After any transaction, the database has to be in consistent state. But base manja inabasa nazo. Not even packet koma transactions like I want a database in consistent state. Here in a basan the eventual consistency at the end of the day, or maybe after a while, database has up in the consistent state. So it's one of the key differences, but we can always go and research to check out my differences at no one ichi. Thanks for that.
Yes, you are very right, Tapia. In actual fact, the base model provides for availability and acid for consistency. Thanks for that.
Yes, we are right, Ishmael. And I think for my examples, like acid, I think they always give example of like let's take of a bank statement or a transaction within in a bank. That's a form of an acid. Then we talk of when we talk of base. Correct me if I'm not wrong. If I'm wrong, we talk of like platforms like WhatsApp, Facebook, Twitter, where we are saying that there is no consistency. I think checking from those my examples, we can find something to exam.
Thank you, guys. Thank you, Tinashe, for the presentation. If there's nothing further to add on, I think we can move on to the next team. Kumisani?
Hello, Angel, how are you?
I'm good, how are you?
Yes, can I present for question 3A?
Please go ahead.
Are you seeing my screen? Hello?
Yes.
Are you seeing my screen? I was saying distributed cloud computing and grid computing using their architecture diagrams. So I had network challenges before, so I will just try to make this quickly. So a cloud computing refers to a client-server computing framework where resources are managed in centralized fashion. It is provided as a pay-per-use service. Cloud computing makes the system accessible all the time. So the cloud computing architecture is combination of self-oriented architecture and event-driven, which means it has got two types of the front end and the back end, whereby the front end is used by the client, and it contains the client-side interfaces and applications that are required to access it. For example, you've got your browsers, your Chrome and your Firefox, and so forth. And then the backend server, this is where which is used by the service provider. That's where we have the server and everything. So it manages all the resources that are required to provide cloud computing services. So the architecture diagram, I will not go, since I shared this in the group earlier, I will not go in detail with this one, but I'll just go to the architecture diagram, which is something about here. So the actual cloud computing there it's a client infrastructure whereby the client infrastructure is connected by the internet to the servers in the storage and the infrastructure, whereby the front end and the back end, they are both connected by the internet, right? So now we want to go to grid computing. So grid computing refers to a network of the same or different types of computers whose target is to provide an environment where a task can be performed by multiple computers together on a need basis. So we are also for a single machine. So in basically all machines or that network work under the same protocol to act like a virtual supercomputer, and the task that they work may include analyzing huge data sets or simulating situations which require high computing power. So computers on the network contribute resources like processing power and storage capacity to the network. So in grid computing, it is a subset of a virtual supercomputer. So the structure of the grid computing network is just like that one. So let me go to the diagram, the architecture diagram of this one. I got this from geeks.com. I don't know if it is able to suffice, but it is what was available. So as we are saying that it can also be seen as a form of parallel computing where instead of many CPU cores on a single machine, it contains multiple cores spread across various locations. The concept of grid computing isn't new. Am I with people or I'm talking a lot?
We can hear you.
All right. So basically we're saying a grid computing network mainly consists of three types of machines. That's the control node, which is a computer, usually a server, a group of servers which administrate the whole network and keeps the account of the resources in the network pool. The provider, which is the computer which contributes its resources to the network resource pool, and the user, which is the computer that uses the resources on the network. So now we are going to what the main question was asking about, whereby we are distinguishing between cloud computing and grid computing. So in the architecture, cloud computing follows a client-server computing, as grid computing follows a distributed computing as centrally managed, whilst in grid computing, resources are managed on a collaborated pattern than grid computing, whereas grid computing is less flexible. Then on payment, cloud computing users pay for using cloud computing resources. They need not to set up anything. They use the platform as a service. Whilst in grid computing needs to be set up first, and the user does not need to pay anything once setup is done. And then accessibility. Cloud computing is a highly accessible service. You can access it anytime, whereas grid computing is low on accessibility as compared to cloud computing. That is what I have there. I don't know if that justifies the question or I've missed it somewhere.
Thank you, Jumisani, for that presentation. Guys, guys, questions, interactions.
Thank you. It was in depth, actually. Mr. Magoche managed actually to articulate all. Handigoni kutsanangura nechirungu, but chandinoziva ndechekuti grid computing macomputers anoita mubatira pamwe, asi imwe naimwe ichibva mukachigrid kayo kainenge iri, either network yacho ikoko dzemakombiyuta dzacho ikoko, obatirana pamwe chete, okonectana maapple, maiphone, maitel, zvimagroup zvongobva zvakaita like that. Why list the other one, which is cloud computing? It's actually all of them, they are centered on one server, normally which is hosted somewhere else, and esarenga achindo lingara through an application. Ndo zvandongoziva wezvo.
All right, thank you, Jeremiah. If there are no further questions,
Hello.
hi, Tapio.
Hello. On grid computing again, we have the computers which are interconnected for the purpose of sharing resources and processing power. We use that usually to complete a certain project. Like you want to develop for example, cat portal. We have a machine that is being used by Jeremiah, the other one by Angel, the other one by Tumisan, and the other one by Mishek. We say, Angel, you are going to do module number 1, then Jeremiah do module number 2, then Mishek the other one. We are sharing the resources. Say, when Angel is done and Jeremiah is done, then we merge the tasks, then we come up with one product. So that's all about grid computing. It's all about resource sharing and improve the processing power in order to achieve a certain task, like completing the development of a cat portal project. Thank you.
Thank you, Chinos. Any additions, guys, before we move on?
I think, sorry, Ishmael Data. All right. Saka, for, I think, as well, for my type of my operating systems and Shanda for the two, for cloud computing, you know, wanzoshandisa my hypervisor or my virtual machine, on which multiple operating systems anogona ushanda, and it then per grid computing, any standard or normal operating system can actually work. Meno pane vane mubvunzo here?
Can you kindly repeat your explanation? I didn't get.
All right. Cloud computing yatachitaura handiti tiri kuti ma-resources ese are in a package, sort of a package, one system handiti. Iri kuconnectwa nema-different devices, nema-different workstations. Handiti, this is cloud computing. Then in grid computing, tiri kuti ma-resources angori pane munhu wese. Like chinos anenge ane mushini wake waari kudevelopa, ari kuita zvaari kuita, Ishmael ane zvake, Homies ane zvawo, tese tirongoshanda on a certain project tichiita tichikandirana information or something like that. Zveva grid computing. So for cloud, like the difference now for my different operating systems that tinoshandisa, for cloud computing it uses more like my hypervisor and it's my virtual machine, like atiri kushandisa ku ethical hacking ana VMware ana virtual box, wekuti we can actually have multiple operating systems and anenge achishanda. But for grid computing now, any standard or normal operating system can work. Sekuti chinos anenge achitoshandisa Windows yake itongori simple, then topindo ari kutongoshandisa Linux yake iri simple, but tese turongosangana pakati on the same project. And izvo kuti zvanzwika.
Yeah, thanks. It's now making sense.
Sorry, Nina, I did not speak.
It's okay. Maybe I may put
maybe
it.
Not gonna give phones.
I may put it in the way how he's trying to put it across. When you come to cloud computing, maybe mukanzo kwatabva kwachina kuti cloud computing. I want to take, for example, there are many device terminals which are connected to a centralized maybe server, which is somewhere else located, sometimes geographically dispersed, right? So by virtue of that structure, it ends up using my hypervisor machine or my virtual machines and operating systems thereof, because we are trying to connect something which is far away, in existence, intangible, and the like. At the end, my hypervisor machine or virtual operating systems. Then when it comes to grid and then from there, maybe for the purpose of increasing storage or maybe operation efficiency, etc. Then after that, from that grid, we connect it again with another set of machines, maybe from another office, because they are at a certain workstation, which is sharing a local network there. Then maybe we are now connecting to another set of station, which is maybe in Bulawayo, while we are in Harare. But there in Bulawayo, they have their own set or a on grid. So on that situation, any standard software or application or operating system can apply as compared, which is grid now computing, as compared to the cloud computing system where we may use virtual operating systems. I'm not sure if it is clear also.
Sagapa grid, depending about your computational power.
Yes.
What I'm working on, it can run on it can be processed on someone's machine.
It's about resource sharing or resource allocations.
All right, think of it this way.
I think the chow
I think all right. Think of it this way. Think of it this way. Pauno enda pa Google Drive yako. Pane storage yema contacts, pane storage yema pictures, pane storage pane ma different ma Excel sheet and pane ma Google documents anovhura ma different types of ma office documents and it. That's your Google Drive. Saka Google Drive yoyo ndo yatiri kuti that's cloud computing. But manje kana takubatanidza mishini yedu takuti nyaradzo iwo necomputer yako endapo, but iwewe ndiwo uchange uchivhura maexcel documents yeproject yedu. Inini ndiri panapa ndichange ndichichengeta kana mapictures. Chinos ari uko achange achiprocessa something else, and kana kuti anochengeta macontacts. Then ichiedzawo maybe ari kuita zvema-emails chete. That's grid computing. But cloud computing tirongoti taenda paGoogle Drive yedu ine different. Saka tiri kuti chinhu chiri kurana paGoogle Drive, and that's a virtual. Yes.
Ndaona wanga wakutodarika paonga set up zvokuti wochengeta ma-pictures, iwe wochengeta ma-word documents, iwe wochengeta ma-excel documents, iwe wochengeta ma-html maybe documents, itisi handitika macomputers akasiyana, mahardrive akasiyana. Then there is a client who is outside the organization, tongoti ari kungoenda paweb, arikuda ma-resources iwayo kuti aone, ari kungondoona zvese zviri pa1, achiona zvese pakati portal, pachibuda mapicture of maprofessor achikepa, pozobuda zvemaresults ake, pobuda but haazozivi kuti zviri kubva kumahardrive akadini akasiyana.
Ndizvo tiri kuti manje Jedza anogona kunge ane Windows 10, Ishmael anogona kunge ane Windows 7, maybe kana kuti iwewe une Windows XP, which means these are normal operating systems ari pama different machines, ari pa grid computing. But for cloud computing, it has to have a hypervisor or a virtual machine iri kutorana ipapo, sekuti Google Drive yacho maybe iri kutorana ne some type of Android operating system.
Okay. Another example ye-grid computing yamakaitiswa naJeremiah paya iti create an Excel document rine ma-details enyu, emails chichi nema-names, that register riya. Handi waindosvika iwe uchinotaipa zita rako uchiona zita umwe wachitaipawo zita rake pamusoro perako. Iwe maybe you were using your iPhone, the other one using Core i7, mumwe Core i3 chichi. That's another grid computing type up to come up with a whole Excel document, name details as a class.
Thanks, I now understand.
All right, guys, thank you so much. That was clear. We move on. Question 4. Question 4A, part 1. Tino Malvin, kudakwashe moyo, tinashe marume, are you in? Okay, I guess they're not in. Michael, Mchena, Nyasha, and Mujaji for question 4A, part 2.
Evening.
Hi, Kuda.
Zviri kufamba here.
Mbichana, you can go ahead.
Unfortunately, I don't have anything to share, but I will just try to run down something which I have.
Okay, hopefully you'll be able to share it with the group.
Later, of course, yes.
Okay, thank you.
So I'll be doing part B of question 4, which is key value databases. The question is explain in detail the following types of NoSQL databases. Then part 2 is key value databases. So basically, there are about 4 types of NoSQL databases. That is the document database, key value database, wide column stores, and graph databases. So key value databases are also known as key value stores, and it's claimed to be the simpler type of a database where each item contains keys and values. So a value can be retrieved by referencing its key. So key value databases are great for use cases where you need to store large amounts of data, but you don't need to perform complex queries to retrieve the data. And possibly examples of key value databases are Redis and DB. So when fetching data, it is fetched by a unique key or a number of unique keys to retrieve the associated value with each key. So values can be simple data types like strings and numbers or other or complex objects. So how do they work? They associate a value with a key, which is then used to keep track of an object. So it works like possibly a dictionary or possibly an array or yeah, something like a dictionary or an array. I think we all know what dictionaries are like and arrays. We did arrays for Python. So it is stored in a persistent way and managed by a database management system. And also it uses compact, efficient index structures, which makes it able to quickly and reliably locate a value. I think I've said that already. So, and possibly it's ideal for systems that need to be that needs to find and retrieve data in constant time. So some basic features are defined by the fact that it allows programs to retrieve data by keys, that is, e.g. by names, identifiers, etc., that point to some stored value. Key value databases are defined as so simply, but they can be extended and optimized in numerous ways. And so the common features of key value database are normally we are dealing with retrieving data, deleting the value, retrieving the value, deleting the value, setting it up and updating and replacing the value. Those are the key features that no kwanisa kuita pa key value database. I think that is what I prepared. If the other team members are there, they can add. Thank you.
Thank you, Kuda. Questions, guys. Team members, if you have anything to add. Okay, I'll take silence for contentment. So we'll move on to the next question. Question 4, part A. Question 4A, part 3. Clement Tembalami, why is Tinashe? Okay. Shekani, Christine. Hello.
Okay.
Tembalami, you can go
Yes.
ahead.
Let me present what I have, then my other colleagues will add.
Great.
Okay, so the graph database is a technology for data management designed to handle very large sets of structured, semi-structured, and unstructured data. It helps organizations access, integrate, and analyze data from various sources, thus helping with their big data analytics. So graph databases are formed from nodes, properties, and relationships, all in a very interlinked data structure. It supports advanced rich querying with scalability. Right. In this model, relationship matter just as much as the data itself. In essence, it combines the querying power of relational databases with the intuitive flexibility of column non-relational databases. So the graph databases are more flexible, dynamic, and lower cost in integrating new data sources than relational databases. Able to store, retrieve, integrate, and analyze high-velocity data coming from many locations. The graph database makes content management and personalization easier due to its cost-effective way of integrating and combining huge sets of data. This is what I have from my side.
Okay, thank you guys. I think zviri kufamba, ndiri kuona muri kufamba nebhora. Taita ma value key, tikaita ma graph databases. But in all those ones, I'm not seeing mechizopawo kuti anoapply papi. Where exactly do we apply them? Say you yakanzi value key, ndaifunga kuti sezvo ndichingonzi value key store. Ndaifunga kuti muchataura kuti inoshanda kuma supermarkets and the like. Paya paunoti majarini code yacho ichi chakati code yacho ichi, that's exactly the value key. Or even pama schools reg number yemunhu zita rotobuda, panja reg number yemunhu zita rotobuda. Even also when it comes to the graph databases, where exactly do we apply them? If we maybe kuna vanotera vakuzotitira the other questions, vazotiudza kuti where do they apply them, so that we can be able to tackle, since the exam kwakanzizo, be able to give examples where they are being applied. That's the hint which the meme gave us. Thank you.
Thank you so much, Jeremiah. Maybe just to add, key value is applied possibly also in gaming and some areas, the finance. Thank you.
All right, thank you.
Then my graph databases, we can use them in supply chain mapping.
All right, that's fine.
I think chimwe chinokwanisa kutibatsira, sorry, chimwe chinokwanisa kutibatsira pane madiagram atakapiwa that PowerPoint yatakapiwa big data analytics. I think should be topic 3. If you can maybe what explainer, then you just put that diagram. Yekuti key value yakadai, graph yakadai. It can also help in terms of giving examples and explaining.
All right, that's fine. In the interest of time, we're left with 10 minutes to go to 11 o'clock. So I'm not sure if we can take on another question or we call it a day. Let me just check. Yes, Anna Chinos no, don't. Chinos, Anna Chinos Avasati. We are left with question 2 kwasara part B and part C. Question 1 kwasara question 1A part 3. Then question 4 kwasara part A 1 and B and C. So we've got about 1, 2, 3, 4, 5, 6 questions left from the whole question paper.
Okay, so did you get any feedback from the presenters as to their challenges, or if they are going to present tomorrow as well?
I have only one excuse from Elizabeth, not knowing if it applies to the rest of the team, but Elizabeth was not ready for the presentation today. Then the rest of the team, like question 4 part B and part C. The other ones, no feedback as yet.
Maybe Chinos will respond for his group so that we know if they are taking the researches or they can be reassigned to some other people.
Chinos.
About network means.
All right. Let's just say we can call it a day. Then the rest of the team, if you've got your contributions, you send them through to the group for compilation. And probably tomorrow, if we are able to start off with the remaining questions and move on to the business of the day. If we are comfortable with that, we can go that way.
Sorry, I wanted to ask, was the session recorded data for today? Sorry to ask that.
I would like to think so, considering that Tinashe Marume is in the discussion.
Thank you. Maybe Tinashe, if possible, just to share. I joined the Mapakati Saka. Just wanted to benefit from Tanga Quick Tanga. Apologies on that on that one.
All right, it's fine. So I think we can now conclude and we meet tomorrow. As to tomorrow's agenda, it will be shared by Nancy.
Hi, Angel.
Hi.
Okay, so Nancy had assigned me a task. She indicated that she doesn't have ZESA, so I will share the question papers that she had shared. She had indicated that I will share them at the end of the presentation as well as the names, and then Ngoni will be chairing tomorrow. So we are doing research methods.
Oh, okay.
All right.
Okay, thank you, Tim. We meet tomorrow.
Thank you, Angel.
Thanks.
Tapiwa.